We are talking about indicator species, more very important parts of our ecosystems. Let's go. So these indicator species can also be called bioindicators, but they are super important to those of us who are trying to understand the state of an ecosystem or the health of an ecosystem. Their increase or their decrease in population kind of indicates a change that has happened, whether it's the availability of food, the condition of the environment, or so on. They're normally very, very sensitive to very specific environments and very specific conditions. They have a very small tolerance to that range. And because of that, we often see large changes when the environment goes through very small shifts. A great example of an indicator species are actually lichens. I know you've seen lichens. They're all over rocks, they're all over Korea. And as I mentioned in previous videos, they're a combination of a fungus and an algae. It's a symbiotic relationship. So the two of them together are what create these here. Now, lichens are very, very sensitive to air pollution, especially sulfur dioxide, which happens due to a lot of industrial combustion. So we can look for bushy lichens, leafy lichens, or crusty lichens. Normally we see a lot of crusty lichens, but the amount of each of these kind of helps us tell and helps us understand what are the levels of pollution in the atmosphere. So let's start with our bushy lichens. These are extremely sensitive. They only have a very, very narrow range that they can actually tolerate. They only thrive in clean air, and so, like I said, very, very, very small range. So when we don't see them, we know, okay, our air is not clean. Then we have our leafy lichens. They can tolerate some air pollution, a much wider range than our crusty ones. So they tell us, okay, well, we don't have a ton of air pollution right now, but it's not super. And when we see only these crusty lichens, that's not a good sign. The crusty lichens are saying that we have high levels of pollution because these leafy lichens can't handle it anymore. And most importantly, this is like a massive red flag. If there are no lichens anymore, that means we have extreme levels of pollution of this SO2, which is quite dangerous, the sulfur dioxide, and we need to really do something about this. Now, these indicator species can be anything from an apex predator all the way down to a bacteria, like an E. coli. But they're most important to us because they're sensitive to these specific changes in the environment, and then we use them to monitor those changes. So let's look at E. coli here. E. coli is in our intestines, our guts, and most mammals, including humans. So when we see it in the presence of streams or ponds, that means that somehow we're getting sewage or feces into the water, and that's not good. So it helps us understand if there's leaks, if there's sewage, if there's contamination in those ponds, which are going to cause a large impact on that ecosystem. Now, the wood stork is a fascinating one. This is in the Everglades wetland area. If you don't know where the Everglades are, these are in Florida. We're going to talk so much about the Everglades because they're a fascinating ecosystem. But the wood stork in the Everglades is an area where we have a lot of construction happening around this population. They've been able to use the wood stork as an indicator species to monitor the population based on how they change their policy. As construction and malls and houses are built around these areas, the city is saying, okay, we want you to deviate your water supply, or we want you to add the water to this ecosystem. And they can kind of figure out, like, is that policy having a good impact? Is our species increasing? Is our species decreasing? And they are maintaining kind of that ecosystem. So if the height of the water is high enough for our storks, then the water level is high enough for that ecosystem to thrive. So a very important indicator species in the Everglades. The algae are another one. You should never go into a pond or a stream and see tons of algae on rocks on the bottom of the stream. That means that there's a presence of nitrates and phosphates, too many nutrients in that river system or in that lake. If we have fast moving, healthy moving streams, we shouldn't have that algae buildup. So it's a way for us to understand the pollution in that stream. Sometimes these areas are being polluted. So maybe we have nitrates and phosphates being polluted via fertilizer that's creating this layer of algae. So when we see algae, we know, there's an issue going on here. River otters are another one. They are very sensitive to heavy metals or pesticides, toxins in the water. So even though they're a small creature, a decline of them would mean, okay, we must have lots of heavy metals or we must have lots of pesticides in the water. And that means, again, somebody is polluting the water. Company, industry, organization, but somehow we have a source of pollution. And their presence or absence is going to help us monitor that. So we have a scale here that we use to look at our indicator species. Some things have low tolerance, which would mean it's a healthy stream. Other things have very high tolerances, which means it's probably not. If we see a lot of this Tubifex worm, it means we probably have a lot of pollution. Where if we see a lot of our stonefly nymph, it means it's probably a lot better. It's a healthier stream. So this scale here kind of helps us understand if we see presence or absence of these species, we have a better understanding of the level of toxins or dissolved oxygen. So these species can be assigned a tolerance rating. So pretty much, do they have a high tolerance? Do they have a low tolerance? So for example, our Tubificidae has a very high tolerance. It gets a high number, where I'm not going to try to pronounce it, our Metrobibida has a very low tolerance. So it has a very low number. Then we can create this biotic index. So to do this, we're going to add up some numbers of all the species in the ecosystem or the area that we're looking at, the area of a stream, the area of an ecosystem, whatever it is. So we're going to take our N here as the number of individuals of that species times its tolerance rating. And then we're going to do it again for the next species, for the next species, for the next species. So we're going to sum up all of those, and then we're going to divide it by the total number of individuals that we collect. The higher the biotic index value, unfortunately, the worse the stream index quality. So if we look at this here, we collected 12 of our Metartorobidibida, 3 of our Diasupidibidibida, and 2 of our Tubidibisidibida. And we're going to calculate the biotic index. So 12, that has a rating of 2. 3, if we go back, that one has a rating of 5. And then our last one, 2, that has a rating of 9. So add those all up, divide by the total, which is 17, we get a number that is 3.3. And the health of our freshwater aquatic systems are all based on this number. So if you remember, this is the key points here. The lower the number, that's an indicator of great water. The higher the number is unfortunately an indicator of very poor water. And we're going to talk about some fun indicators. I'm going to show you my chemistry indicators. We have biology indicators, but we have chemistry indicators too. Here we go. All right, here's our own little chemistry indicator. Clear, but now it's, oh, wow. Spill.